start. I'll have to go out and in. I have Desmos. I use GeoBra with my calc classes because it does more things. Desmos is a little bit easier to work with because it's easier to do, but that's just taste. So here is GeoBra. And putting in, let's just put in a baby one to start with. So we want to do sin x. There we are. Not too tricky about that. And let's suppose I wanted to find when it was equal to, say, 0.3. And there we go. If you move your mouse pointer, you can zoom in. Let's suppose I was interested in that guy there. Can you see how much more accurate it is at the intersection point? So if you needed to know that answer to 10 decimal places, well, it looks like it's probably even more than that. You are good to go, right? Very visual, I like it. If I keep my finger on, if I click on this guy, it goes away, right? Put it back. It's got all the usual features. Don't use this one quite as much for single ones. I use the 3D version. Okay, now what was the real question? In other words, the homework question or one like it. So bear with me for a little while longer. Here it goes. We're in section 7.5, solving more trig equations, and these ones are distinctly weird and wonderful, as you would expect. So the one I'm looking at right now is question 7. In a version of question 7, you have a function f of x equal to 6 cosine x plus 3. You have a function g of x, which is the cosine of x take away 2. And they even tell us that it's between negative 2 pi and 2 pi. I won't worry about the y values. And they ask us to graph it. Well, graph both of them because it's two functions. And let's show you how that would work. So back to our beginning. I'm in Desmos right now. You type in y equals 6 cosine of x plus 3. And then you do y equals cosine of x take away 2. And I'm going to restrict it from negative 2 pi to 2 pi, which is why I like Desmos for this at least. Little curly bracket, negative 2 pi less than or equal to x less than or equal to 2 pi. Should be able to hit enter. Here we go. And the second function, oops, take that out. Just copy this guy and then paste it. And there you go. Little shrink. There we go. And in the homework, you were given, I think, four guys, and one of them looks like that. Do you agree Desmos for that does a good job, right? And that would be the first piece of the question done. So next, Phil. Oh, do you want to see it in GeoBra? Just for curiosity. Quite similar, I would hope. Put y in. Y equals cosine of x take away 2. And the one above it. Oops. Don't know where that came from. I'll just start from scratch. Y equals cosine x. That's better. And then this guy over here. Six cosine x add 3. If I shrink back a little bit, there, can you see it's very similar? I just haven't done the minus 2 pi to the plus 2 pi. Now, if you want to know when are they equal to each other, would you agree it looks like it's happening there? And it's happening there. And there's the x coordinates of it. I have Desmos handy. When I switch screens like this, are you still seeing them? Do I have to go out and in? Are you looking at Desmos in color? Right. Yeah. Right. So if I click on this guy here, do you see negative pi and plus pi? Can you see why I like Desmos when the answers are nice values? Do you see how GeoBrig told you 3.14 blah, blah, blah for 12 decimal places? But isn't this one cleaner? So if the answer is pi upon 2 or pi upon 4. So it's not like one is better than the other because they're both strong in different fields, right? So GeoBrig is definitely much better when you have those variables. Well, you know, that guy's okay if it's 5, you know, 2 or 3 or 4 decimal places, but it's not good for 5 onwards. So the first kind of question is, how do you solve an equation when the curves don't play well together, right? And you would do it like that. And the answer that they gave was rounded off to 2 decimal places. So we had one answer at 3.14, comma negative 2, and the other one would be positive 3.14, comma 2. So that's that one. Now, do you want me to do another diagram one where you find where they intersect and use Desmos? Are you comfortable with the one I've shown? Do you want to see another one, or are you good? You good? You'd have fun. Desmos does it, GeoBrig does it. So using the sum and difference formula. Okay. That's not the way I want to do it. Try to be consistent. Did I use A and B last time I wrote these down? I think I did. Right. So we want to do the sine of A plus the sine of B. We want to do the sine of A, take away the sine of B. We want to do sine of A plus the cosine of B, and so on and so forth, right? For instance, you might want to do a cosine of A plus the cosine of B. You remember those guys, which were the sum to product formulas? Now, since I haven't written any of those guys down, and I never bothered to remember them because there are just too many of them, you should remember the double angle formulas, right? Sine of 2 theta is 2 sine theta, cosine theta. But for these ones, I wouldn't get too caught up on it. So we're going to be using these guys, right? And here we are, and the other versions that go with it. So this is example 8, and it's sine of theta, cosine of 3 theta, plus the cosine of theta, sine of 3 theta equals 0. And if you go hunting through all of these formulas, you'll find a guy that looks like this. Sine of A, cosine of B, plus the cosine of A, sine of B. This guy is the sum or the difference of a trig formula. Does anybody recognize who he is? Want to have a guess then before I tell you? Right, what would you do? You'd go and look at all your formula and you scan through the one that had this combination. And if you look, you'll find out it's that guy. Now, since A is this fella and that guy is this fella, this is going to become the sine of theta plus 3 theta, which is the sine of 4 theta. So the original question was pretty much impossible to do. There isn't any direct trig identities that we could use on that one. But when we noticed that they could be combined together using one of the addition subtraction formulas, right? These guys are way over here and all the other ones of them, we got that. This guy I can solve. Agreed? Now, on your unit circle, which I do have, although you probably don't need it for this question, what angle has a sine of 0? Well, it's the angle whose y coordinate is 0.
Would it be 0 or pi?
And it could be 0. Could be pi. I'm doing overkill here. Couldn't it be 2 pi? Couldn't it be 3 pi? And then basically forever, right? Now, I'm looking at the question and finding out what they want us to do. And they want us to write down all the solutions in the interval 0 to 2 pi. Okay, so if 4 theta is equal to 0, then won't theta be 0? So that's one of my answers. If 4 theta is pi, won't theta be pi upon 4? Then divide that by 4 and you get a half. Then divide that and you get 3/4. And well, I can see a pattern here. So all the answers get written down in a big box with commas. And that's what they mean when they say a comma separated list. Well, let's see. 0, pi upon 4, pi upon 2, 3/4 pi. Just be using a pattern. What's the next one going to be? 1/4, 2/4, 3/4. What's the next one going to be?
Pi.
Which is 4/4. Then 5/4. The next one should be 6/4, but that simplifies down to 3/2. What's the next one going to be?
7/4.
Now, I put down a square bracket here, and because of that, wouldn't the last answer be 2 pi?
Mm-hmm.
If it had written 0, 2 pi with a curved bracket, would I use the 2 pi? No. If they put a curved on this side, would I use the 0? No. Right. So, little thing, missed it until I had a second look. Can't use 2 pi. So the trick was to realize that this horrible expression could be combined using one of the sum difference formulas into a single sign that was much easier to solve. And that's how we would do A. The question 9 is cosine of theta, cosine of 2 theta, plus the sine of theta, the sine of 2 theta. And the whole thing is going to equal that guy. It's a lot to ask, but you might get lucky. Cosine times cosine plus sine times sine. Do you recognize anybody who does that?
Yeah, it would be cosine theta minus 2 theta.
Right. Well done. Did you have that in front of you, or you just came to you?
No, I remembered them because I thought cosine was really weird because for minus it was a plus. And stuff.
Okay, so little things that stick in your head, that's good. Now, this fella here is not your favorite, not my favorite, because it's negative theta. And what we've done is not wrong. But if I continued with this negative theta, I would just make my life really weird and ugly, and the numbers I'd get would not come out very nice, because we're only interested in the answers between 0 and 2 pi, and things just get messy. So whenever you combine them and you get an answer that's negative, like negative theta, negative 4 theta, that kind of thing, go back to the original and do this. Would you agree that you can put these in any order you like and it doesn't matter? But if I do it that way, don't we get the cosine of big guy take away little guy? And that comes out much nicer as a cosine of theta. So if you get, you use the formula, but you get an answer that you're really not comfortable with continuing with, and I'm never really comfortable doing these. They just make things weird. Can you see you can switch places and it comes out nice? Now I want to solve this. So I'm trying to find 2 theta is, right? And I'm looking for an angle whose x coordinate is equal to root 3 upon 2. Where's my unit circle gone? Oh, here it is. Well, if I go hunting for the answers, I believe there's only 2. X coordinate of root 3 upon 2 is this one, so that's what, pi upon 6. Where's the other one?
$11 pi on 6.
Yeah. One of my calculus students says I say things funny. I call that pi upon 6. And he says, nobody calls it pi. We didn't say it that way, but that was just of it. Nobody calls it pi upon 6. Are you just that used to me that you know what I'm saying when I say that?
Once upon a pi.
Okay. Once upon a time, right? Once upon a pi, right? I'm pretty sure that I haven't distracted anyone, right? Pi upon 6. You probably don't even notice I'm saying it anymore.
No, not
Did any
really.
of you notice it the first couple of times?
No, not really.
No, you just get
I
used to it.
noticed it, but it makes sense. It's on top of 6. So
Yeah. Okay, that's good. Because occasionally I do things and I don't want to do them if they're distracting or just make you feel wrong. Can we just pretend for a minute that this one, a different question, but let's just pretend that it was this guy. Just to show you that you'd have to adapt a little bit, right? So you combine them together and it was cosine of 2 theta, right? Different question, you got this. Then I would be 2 theta, right, is an angle whose x coordinate was root 3 upon 2. And you would be saying, just kind of like we did last time, you would say, oh, 2 theta is pi upon 6. And that means theta is pi upon 3, right? And then you'd say 2 theta would be 11 upon 6 pi, right? That one. And that would make theta 11/12 upon pi. Okay, so we've got 2 answers. There are more answers, aren't there? There's actually 4 answers in this question. Where are the other 2 hiding? What do I add on to pi upon 3, right? For instance, to get the next answer? And what do I add on to, was that 11/12 we got? 11/12 pi. What do I add on to get that one? Here's your clue. What is the period of the cosine of 2 theta?
It's pi.
It's pi. If you add the period onto an answer, won't you get another answer that also works? And so that would get me, my third answer is 4/3 pi. And my last answer would be, I believe, 23/12 pi. They don't tell you how many answers there are, right? You know, sometimes they used to give you like 4 boxes and you put in the ones and some you wrote none down. In these kind of questions, there could be 10 answers, there could be 2 answers, right? So when you find the 2 that you get from here, add on the period until, you know, the numbers are so big that they're not in the range 0 to 2 pi anymore. And that's the end of that one. We're getting darn close to finishing this question. Oh, we got a different version now. Okay, 10. Cosine of 7 theta, take away cosine of 9 theta. And the whole thing is equal to 0, which is a real pain in the butt because I wish it was some other number, but never mind. We're being asked to use the sum to product formula. So the question does tell you what to use. And if I could find my little list, I would show you, but since I can't, I will go hunting for it. And while I'm doing that, why don't you put your last name down for attendance? I'm basically just typing it into the calculator as we speak, into my thing here. See if I can find one that's that one's not good. It looks a little bit nicer. No, I won't use that one. I'm still scanning here. Apologize for your wait. Found it. Okay. Cosine take away cosine. So cosine of A take away the cosine of B. The formula that I've got for that particular combination is negative 2 the sine of A plus B over 2 multiplied by the sine of A take away B over 2. And A is 7 theta and B is 9 theta. So it's going to be negative 2 times the sine of, add these together, which is 16 theta divided by 2, multiplied by the sine of, you subtract one from the other, you get negative 2 theta over 2 equals 0. And that becomes negative 2 the sine of 8 theta times the sine of negative theta. That one's ugly, but we can live with it. So these two guys subtracted equals 0 turns into this multiplication equals 0. We can now say that the solutions are going to happen when the sine of 8 theta is 0 or when the sine of negative theta equals 0.
And the sine of negative theta also equal the sine of theta?
Yeah, well, actually it equals the negative of the sine of it, but it won't matter in this question. I'm going to keep that negative and show you how to fight through it. Right. When you're looking for when is the sine equal to 0, you're looking for an angle, okay, whose y coordinate is 0. And that happens at 0. Where else does that happen? Where else do you get a sine or a y coordinate of 0?
Pi.
Okay. And would you also get it at 2 pi and, you know, forever? Right. Now, if you just take this one, isn't theta equals 0? Okay. What is the period of sine of 8 theta? How do you find the period then of the sine of 8 theta?
Is it pi over 4?
It will be. It's 2 pi over 8, which is pi over 4. So if I add on pi upon 4s till I get bored, won't that give me all the answers without me having to write this pattern down? And so 0 plus pi upon 4k, which I'm now going to simplify as just pi upon 4k, because we're being asked to find all the solutions this time. So if you did this one, 8 theta is 2 pi, divide both sides by 8, you get a quarter pi, and so on and so on and so on. Right. Now, what about this guy? Well, negative theta is going to equal an angle whose x coordinate is 0. Isn't negative theta going to be 0? Amongst others. And isn't negative theta equals 0 also the same thing as 0? Theta equals 0. And if you wrote down all the versions of that one that existed, it would be 0 plus 2 pi k, which is 2 pi k. But aren't all those answers already inside that one? So the final answer is just that guy. So if you've got a multiple of theta, you only really need to find a couple of answers, you'll see it yourself, and then realize that you add on the period. So in this case, 0 plus period k. If there was 2 distinct answers, right, 2 ones that, you know, because you typically get 2 answers from a unit circle, find the 2 separate answers and then just add on pi upon 4k. Right? So any given 2 answers, pi upon 4. Let me do an example of that then. Suppose I had, at the end of all the working, I ended up with this guy. Then I would be saying, okay, 4 theta would have to be the angle whose x coordinate is a half. And I want all the answers in the universe here, not the first 6 or 8, whatever they asked me, not all the answers between 0 and 2 pi, I could do that as well, but I want all the answers. And whenever you've got all the answers, that k thing is going to appear in your answer. So I go hunting and I find an x coordinate of a half and I get pi upon 3. That becomes, by dividing both sides, that guy. Is there another angle? Because typically you should be looking for 2 with a few exceptions, that also has an x coordinate of a half, and the answer is down here, and it's 5/3 pi. And if you divide that guy by 4, you get 5/12 pi. You with me? Now, find the period of this guy. And that period is 2 pi divided by this number, which ends up in this case being a half pi. All you need to do then is add a half pi k. Add a half pi k. And you now have all the solutions. So you only need to use your unit circle to get the two distinct ones, and then the period part, followed by a k, to generate all the other answers. Now, these are correct, and these are the best versions of correct. Unfortunately, I know from experience that some of you were doing homework questions where it did that to you. Have you seen the questions where they added a 2 pi k? Right. Don't do that. WebAssign might want you to do that. Will you please do them? Now, if you do those and WebAssign says you're wrong, you tell me and I will go in and give you the points because you're correct. WebAssign, and it isn't even consistent. Sometimes they do this and then sometimes they do that and you're never quite sure why. I can't tell why either. Always do it this way, right? And you're fine. And if you get an answer that WebAssign says is wrong, let me have a quick look. If it's okay, I'll just give you the points and move on. So trust the method, even if you can't always trust WebAssign. Are we good? Any questions? Then we have finished everything that I want to do for today. And what I think would be useful, because your time is valuable, is if I just hang about and I'll do some homework questions for those who have any. And those who don't, make sure you've said your last name and bye-bye. And I will be seeing you on Tuesday, because Monday is a holiday. And your solutions to your online test are now online for you. So bye-bye for those who are leaving right now. For those who are hanging about, I'm ready.
So would you mind giving us one, like a problem to do, just so that we can run through the motions?
Oh, yeah. Is it one with the double angle or just the bit at the end where you have to cope with the cosine of 2 theta? What are you thinking about that?
Honestly, just any one, just so I can run through it, just to get the motions and so I know I'm doing it right.
Makes sense. Finding one, give me a minute. I'm going to go into
All right.
WebAssign, and that way I can look up their questions. Because if I just randomly make one up, the numbers won't come out well, right? It won't equal a half, right? It'll equal some weird fraction that you can't get easily. And we want to keep it to that situation. So we're on chapter 7. Whereabouts in chapter 7? Okay. Just give me a little while longer. Still looking for it. There we go. Let's suppose that you were being asked to find the sine of 4 theta plus the sine of 2 theta. And it was going to equal 1. Right? So let me write that guy down. This one should come out nicely, just kind of where it was. So the first thing we're going to do is look up the sum to product formula. And the one that works for this one is the 2 times the sine of those two guys added, divided by 2, cosine of those 2 guys subtracted. So that you would look up, right? So you can just trust me, sine of A plus sine of B is 2 times the sine of these added, divided by 2, and they subtracted. And so I now have the sine of 3 theta cosine of 1 theta equals 1. So far, so good? Right.
Yeah.
Okay, that bit you kind of need to tell point. If I pick you up right, you want to fight your way through this one and then I'll do it to check it, right?
Yeah.
Okay, go for it, guys. I'll leave my unit circle here in case you don't have one handy. Whenever you feel you've got to that point, you can tell me. Now, start working.
So I'm stumped on the sign one.
Okay, let's go. Oh, sorry. My apologies. Does that help?
Oh yeah.
Okay, right. You couldn't have done the other one. It wouldn't have worked. Hey, come here. Come here. Come here. Come here. Oh. Okay. Right. This here is Trixie. She's our latest addition to our family. She's 2 months old, and she's stolen everybody's heart. Mine. And to give you an example of what she's done, this here is a remote. She thinks remotes are chew toys, and she's chewed the heck out of this one. So I haven't checked it yet, but I may not be able to use my DVD player anymore because this little girl thought it was, oh yeah, I'm not, oh yeah. Doesn't she look like an angel? Mm-hmm, yeah. Well, she's not, but we love her anyway. Okay.
She's gotten big.
She has. Oh, let me show you what she brought in as a toy. She loves rocks. She goes out into the yard and brings rocks in. Where has she gone? Okay, I think we've given you enough time. Let's see what this one would be like. So what you're going to say is two things multiplied are 0, which is pretty straightforward. So we're going to go and basically say that the sine of 3 theta has to be 0, and that the cosine of theta has to be 0. And let's assume that they want all possible answers. I'll start with the sine. 3 theta then has to be an angle whose y coordinate is equal to 0. And if I look for places whose y coordinate is equal to 0, I get that guy, right? And I get that guy. And I get that guy. You agree? Now, if you do this fella, you get theta equals 0. If you do this fella, you get theta is pi upon 3. And if you do this one, theta ends up being 2/3 pi. And I could keep going forever, but I don't want to. The period of this function is 2/3 pi. So if you add 2/3 pi, which with a little k on it, you're going to get all the answers that come from this guy. So theta equals 2/3 pi k. Now, if you take this answer and you add on 2/3 pi k, which actually you can't really do any more than what it already is, you get that guy. Now, if you do this one and you add 2/3 pi k, you don't need them. And the reason you don't need them is because won't the first two answers give you everything that you need, right? That answer there is actually just 0 again, isn't it? You went all the way back to the beginning. So there's your two answers from there. Now I have a cosine of theta, which is a bit unfortunate, that one. But the angle I'm looking for here is an angle whose x coordinate is 0. And the ones that have an x coordinate of 0 are pi upon 2. And the other one is 3/2 pi. So there's the only two you need to go hunting, right? Only hunt for the two that are in the unit circle. Now, what is the period of cosine theta? Well, that's a baby one, because isn't that 2 pi? And there is the 4 solutions. Really the 4 family of solutions, right? 1, 2, 3, 4.
Could you move your paper down a little bit? Or I guess up.
That help?
Yeah, thank you.
Okay. Yeah, you needed 0 there, or that question wouldn't work.
Yeah.
I was wondering if we could do the sine of theta over 2 minus 1 is equal to 0.
Oh, that's a good one. Is that a homework question or just one that you saw that looked interesting?
It's a homework question. For me, it's number 6.
Right, let's have a look at this one. So I need my unit circle. I'm going to start with theta upon 2 take away 1. Not a very nice answer, but this guy, if it's going to equal 0, aren't we looking for points whose y coordinate is 0? And so we're looking for 0.
Oh, the negative 1 is actually outside of the parentheses.
Oh, different question. So it's going to be that guy, right? So what I'm now looking for is, what does theta over 2 equal? Well, I'm looking for a y coordinate equal to 1. And most of the time, there are always 2 answers, but there are exceptions. And would you agree that there's only one place right now that has that? And that's the angle pi upon 2. You with me so far? Right. Normally you'd get 1 here and 1 here, or 1 here and 1 here, right? Normally you get 2, but in this case there's 1. That's not a big deal. If you multiply both sides by 2, you get that answer. And then you factor in the period. Okay, what is the period of that guy? If I write him as a half theta, I don't know if that makes it better or worse, but the period of that guy, isn't it 2 pi divided by a half? And so the answer ends up being 4 pi. So plus the period, k. And there's all your answers. Now, if there had been 2 angles, it would have been the first one plus 4 pi k and then the other angle plus 4 pi k. Did that help? Did it make sense?
Thank you.
Any other suggestions? Any other questions that might help? Can I leave this as part of the video so anybody who goes back and watches might get some help on their homework? Thank you. Any more?
Could we do one that's like longer, where it's like sine of something plus cosine of something, etc.?
You can't actually get a sine plus a cosine.
Yeah.
Those two don't play well together, unless it's one like this. I changed my mind. Is it one like this? Oops, restart it. Does it look something like that? Is that the one you're sure? Right. Well, in this case, you divide both sides by cosine. And what that does is it gives you 2 tan theta equals, I mean, that's square root of 3. Square root of 3. Just change the question so it come out nicer. And now we have that. And unit circle. It's a little bit harder to do these because you have to kind of do calculations in your head. I don't think that's actually going to be an exact value. Yeah, it isn't. So theta is going to have to be the inverse tan of root 3 upon 2, which is fine. Inverse tan. Oh, which mode am I in? Okay, I'm in radians, so that's important. So inverse tan of root 3 upon 2. And the answer I get is 0. Let's just call it 71. Where is the other answer? Because I can't really use my unit circle because it's not an exact value. But where is the other answer? Well, we have all sine, tan, cos. The one that we found here is that one. Which other quadrant do you get your second answer in? Where is the tangent positive?
3.
3. And that's pi plus this angle, which is whatever that is. So pi plus 0.71. That guy is about 3.85. And if you wanted to do all the answers, right, all the infinite number of answers that there could be, the period of the tangent function, can you remember what that one is? The period of a tangent function.
Would that be just pi?
Just be pi. So you do a plus pi k and a plus pi k. Now, if that was a nice number, like, you know, pi upon 6, then I'd do pi upon 6 plus that, and 5 pi upon 6 plus that. Just the question I made up didn't come out very nice. But still doable. Can we imagine a question
Wait,
where,
so technically,
yes,
don't we only need to use the 0.71 pi k plus pi k?
in this time, yes, because that one gets used up by the other one. Yes.
Okay.
Can we imagine that we got the answer to a question and it ended up being pi upon 3 plus pi upon 2k, right? That was the general answer. But they only wanted the answers in the range 0 to 2 pi. So we found that, but they only want the answers from 0 to 2 pi. And you might say, well, how am I going to find what these answers are? Well, if you plug in k equals 0, you'll get your first answer. If you plug k equals 1, you get this, and that ends up being 5/6. If you plug k equals 2, you get that answer. And if you plug k equals 3, you get that answer. Well, I think that's 23/6, but let me double check. 1/3 plus 3/2, and then make it a fraction. It's 11/6, as I thought it might be. Right. And if I found one more, wouldn't it just be 4 there, right? That would get me to add 2 pi, and that one would end up being 7/3 pi. But wouldn't I stop because that one's too big? And that would be the answers that fit within the range that you were hunting. So if you get one of those questions where you're being asked to write all the answers from 0 to pi or 0 to 2 pi or whatever it might be, can you see you can still use this by just plugging in 0, 1, 2, 3, 4, 5 until you get to a number that you can't use? And how would you think you could get the negative answers? Because I have seen questions where they only want the answers, say, in that range, right? How do you think you could get the negative answers still using that formula?
Do you just subtract the 2 over pi?
Yeah, subtract 1, 2 over pi, subtract 2 over pi, subtract 3 over, whatever it takes until you get outside the range again. So in a way, finding this formula, even if they don't ask you to, isn't this finding this formula helpful in those questions where you have to write down all the answers in a certain range? Because it's very easy to write down the first 2 or 3 and then think, I don't know where to stop, right? I don't know if I've reached the end, or, you know, is there one that I've still to find, or, you know, whatever. So if you get this guy, plug in nothing, 1, 2, 3 until it gets too big. If you need to do negative numbers, just plug in -1 for k, -2 for k, -3 until you need to stop.
So couldn't you also technically just put that in Desmos, right?
That one would probably come out pretty good in Desmos because Desmos tells you pies.
Yeah.
You're right. It wouldn't give you the general formula, but it would give you these answers.
Yeah.
Would you remind me which, is it like the bracket or the parentheses that includes endpoints? I know you're talking
Sure.
about it.
Okay. I'll put numbers in like 0 and 1 just to keep pies out the window. When you see a square bracket, that's what I call them. I don't know what Americans call them, but I call them a square bracket. Actually, you call them parentheses, now I think about it. If you see that shape, it means include the number. And if you see that, which I call curved brackets, don't include the number. Don't use it in other words. So square bracket, use the number. Curved bracket, don't use the number. I'm going to keep using those terms because I've used them too long in my life. But what would you call those guys if you were using it? If you were wanting to tell me out loud? What's that guy called?
I probably call that one a bracket and then the curvy one a parentheses.
Okay. Oh, so my terms are a little bit confusing because I use both brackets. But you know, now you know what I mean when I say square bracket, curved bracket, right? Once you've sorted that out. I kind of like it, right? Curved, kind of square. I mean, to me, it makes sense as a name.